All right, welcome to my YouTube channel. Today we're going to be looking at physics 101 basically. Now I'm going to be solving 30 questions from a particular past question. Now these 30 questions would cover a good enough scope of the Physics 101 syllabus, right, of the outline, but it may not cover every single thing, right? But I believe that with what we're going to cover here, it is going to go a long way to help you in your Physics 101 examination. All right, so now let's dive into it. All right, so we have question one here. Hold on. Right. So we have question one. The question says the motion of a body relative to itself is, we have option A to be zero, option B to be uniform, option C to be accelerated, and option D to be variable. Right. The motion of a body relative to itself. Right. When we say something is relative to something, it means that we are taking something and then we are comparing it between two things, right? So now if I'm taking a body, right? And I'm taking the motion of that body. Let's say that body is moving, right? But that body is stationary. It is just there. And I say, what is the motion of this body in comparison to this body? It is still the body, right? So it's basically going to be zero, right? The motion of a body relative to itself is going to be zero because you are still taking account of that same body, right? Now, if just like if a person is inside a bus, or if you are inside a bus and that bus is moving, you and the bus are moving at the same exact speed. But when you look at yourself, it does not look as if you are moving. But then the bus looks as if it is moving very, very fast. But you and the bus cover the same distance in the same time, right? So that means the motion of a body relative to itself is zero. So go to question two. Question two says the acceleration of a body with constant velocity is, the acceleration of a body with constant velocity. Now, one thing I would like you to understand is that acceleration, right, A is equal to the change in velocity over time. So if there is no change in velocity with respect to time, then there cannot be acceleration. Do you understand? If velocity is not changing, then there cannot be acceleration. Now, this question says the acceleration of a body with constant velocity. When something is constant, means that it is unchanging, it is not changing, it is stagnant, right? With constant velocity. So the acceleration of that body is going to be zero because it has constant velocity. Do you understand? So that is for question two. Then question three now, we have what is the dimension of force? When you see questions on dimension, they are cheap marks, very, very cheap marks. Now dimensions, we have three basic fundamental dimensions, right? We have for mass, let me change this to a pen, right? We have for mass, we have for length, and then we have for time. Length is the same as distance, right? So now the dimension for mass is m, dimension for length or distance is l, and dimension for time is t. Now basically, why do we use dimension? We use dimension to represent formulas, right? Quantities in terms of letters m, l, and t, right? These are the basic ones. We use dimension to represent, that's this is why we use dimension, right? And dimension also helps us to check the validity of an equation, right? So I can just come, anybody can come and tell you that force is equal to volume over speed times, let's say, velocity, right? Now, this thing might be correct, it might not be correct, but if you do not know whether it is correct, what you're going to do to determine whether this formula is correct is that you are going to use dimensions. Once you use dimension and you take the dimension of the right hand side and the dimension of the left hand side, if they are equal, then you will say that yes, the formula is correct. But if it's not equal, you say it's not correct. So that's basically one of the uses of dimension, right? So now that's why we use dimensions. So now we also have these dimensions, and then we have other ones too. We have dimensions for temperature to be theta. Then we have for ampere, current. Let me just use current. For current to be A, or I, depending on the textbook that you're using. Some textbook use A, some textbook use I, depending on the textbook that you're using. So it's either A or I. So we have that. The number of modes is basically a number, right? And then which other one do we have? Right. So let's just continue with this. If we see a question that needs us to add another one, then we add it. Right. So we have mass m, length or distance to be L, time to be T, and temperature to be theta, current to be A or I. Some textbooks use J as well. Or this is J for current. All is still the same. Right. So now this question is asking us for the dimension of force. Now the first thing you do when you see questions like this is that you find the formula of the quantity that you are being asked to do. Right. So now this one they're asking us to do for force. Right. And our force is equal to what? Mass times acceleration. Now, once you have found the formula, the next thing is to break down that formula into the simplest bits, right? You are breaking that formula into the simplest bit. So, what I mean by that is that you are going to put the formula in a form that has only mass or length, time, and current, all those fundamental quantities. Acceleration is not a fundamental quantity, it's a derived quantity. So that means we can break it down. Mass is a fundamental quantity, so we'll just leave it like that, right? So we're going to have equal to mass, and acceleration is what? Velocity over time, right? And we can still break down velocity because it's a derived quantity. So velocity times distance over time, then everything over time. So now you can see that you cannot break them down again. All these quantities that we have here, they are fundamental quantities. Distance, time, they are all fundamental quantities, right? And remember that mass is m, distance is L, and T is for time. So mass now we're going to say m times distance, which is L over T, then all over T. Then this will be m times LT minus 1, right? According to your laws of indices, then we have T here. Then we have m times LT minus 2, right? And this gives us MLT minus 2. So this is dimension for force. I think that is option A. So very, very simple stuff. Then we'll go to the next one. We have question 4 now. Now for question 4, it says the relative velocity of a body to itself. Right, just like question A, the motion of a body related to itself, right? Now we're dealing with the relative velocity of a body to itself. It's still the same thing, right? Since it is that body that is carrying out that action, when you take it relative to itself, it will always be zero. It will always be zero. The relative motion or the relative velocity of the body with respect to itself will always be zero. It is now when you take it in account to another body of different velocity of it or of a different motion, then you have a different value other than zero. Right? So question 5 now says the velocity of an object with respect to itself, the same thing, right? The same thing. So now question 6, we have d1 to be equal to d1 is equal to 3I minus 2j, and d2 is equal to 5I plus 3j. The question says we should find 2d1 minus 2d1 minus 4d2. So basically what we're doing is we're doing 2 multiplied by d1, which is 3I minus 2j, minus 4 multiplied by d2, which is 5I plus 3j. So we have 2 times 3I, which is 6I, minus 4j. Then we have minus 20I plus 12j. All this in bracket, right? It's in bracket because I've not opened the bracket here. So we have 6I minus 4j. Then minus times plus 20 will be minus 20I. Minus times plus 12 will be minus 12j. So we have 6I minus 20I, which is minus 14I, minus 4j minus 12j, which is minus 16j. So we have that. Very, very simple stuff. All right, so we'll go for the next number now. That's number 7. Go for number 7. Now, number 7, we have A minus B. If A minus B is equal to 2C and A plus B is equal to 4C, where C is equal to 3I plus 4J, they said we should find B. So we have two equations. Equation 1, A minus B is equal to 2C, right? And then equation 2, A plus B is equal to 4C. So what we're going to do very quickly is we're going to find B, right? And to do that, we have to first make A solve the formula. So we can impute A in the second equation. This is what I mean, right? So we have A minus B is equal to 2C, right? So we can say A is equal to 2C plus B. Then we impute this equation 3 into equation 2, right? So we can say 2C plus B. Remember that, right? Because A plus B, and A is what? 2C plus B is equal to 4C. So here we have 2C plus 2B is equal to 4C. So we have 2B is equal to 4C minus 2C. Then we have 2B is equal to 2C. Then we have B is equal to C. So now because B is equal to C and C is equal to 3I plus 4J, then that means B is equal to 3I plus 4J. Option A. Very, very, very simple stuff. Right, and then we take question 8 and then we move on to the next section of our questions. Question 8 says, which of the following is a wholly fundamental quantity? Now, wholly there is just English. What wholly means like totally or fully or completely. That's what wholly means, right? So which of the following is totally a fundamental quantity, or is fully a fundamental quantity, or is completely a fundamental quantity? Now, if you look at mass, we have pressure, we have density and force as the options. Mass is the only fundamental quantity there. Pressure, density, and force are not fundamental quantities. So it means the answer to that question is going to be option A. All right, so let's go to question 9. So now question 9 says, if a body moves at 10 meter per second north and body Q moves at 10 meter per second south, what's the magnitude of the velocity of P relative to Q? I'm going to teach you a trick on how to always get your correct answer in this question. Now it says P moves 10 meter per second. 10 moves with 10 meter per second to the north. North is upwards, right? 10 meter per second. And then it says this is for P, then this is for Q. They say Q moves 10 meter per second in the opposite direction, which is the south. Now, one thing you will do for this kind of questions is that you first assign one direction to be positive, right? So you're going to say here, let's not be positive. Let not be positive. So if not is positive, the opposite of not, which is south, is going to be negative, right? So this is going to be plus 10 and this is going to be minus 10. Do you understand? So now they say, what is the magnitude of the velocity P related to Q? So we're looking for PV P over Q, right? So this is going to be VP minus VQ, right? The magnitude of the velocity of P related to Q, right? We're always subtracting this from this VP minus VQ. So because they are in different direction now. So now we're having VP, which is 10, is going to be positive, right? Because we say let not be positive. And VP is the direction of the body P, right? That's the velocity which is 10. And since we're saying not is positive, then that means that term must be positive. Then we have minus VQ, which is in the opposite direction, south. So that one's going to be minus 10. So here we have 10 plus 10, and this is 20 meter per second, right? So that means option C is correct. So the magnitude of the velocity of P relative to Q is going to be 20 meter per second. So how do you do this? You assign a positive side to one direction, then the opposite direction will automatically carry the negative sign, and then you use your formula V VA minus VB, right? The reason why I used P and VP minus VQ because of the letters that were given in the question, but ideally you just use VA minus VB. Right, so now question 10. Which of the following is true of an inertial reference frame? Inertial reference frame. Now, an inertial reference frame is a frame that follows the Newton's first law of motion. Now, what is the Newton's first law of motion? It states that an object will continue in a state of rest or in constant motion unless acted upon by an external force. So if there is no external force on a body, then it's going to continue in a state of rest. That is what the first law tells us, and a body that obeys the natural reference frame obeys the Newton's first law. Have that at the back of your mind. Now, option A says Newton laws do not apply. That is obviously not correct. So I already told you that it obeys Newton's first law. Option B says it moves with constant velocity or is at rest, which sounds a lot like our first law. So meaning that is our answer, and we don't even need to check option C and option D. Now, option 11 says, which of the following is not true of Newton's laws of motion? Right? We know the first law, the second law, and the third law. The first law is what I just stated. The second law talks about mass, right? The formation of mass and relation to force and acceleration. Then Then the third one talks about action and reaction, equal and opposite. Right now, let's look at our options. Which of the following is not true? Right? Option A says force equals mass times acceleration. That is true from Newton's second law of motion. Action and reaction are equal and opposite for option B, which is true. That is Newton's third law of motion. Then option C says force can exist without interaction, which is not true. Force cannot exist without interaction. You cannot keep a body on a table and then nothing happens, nothing touches that body, and then it just begins to move. Right? There must be an interaction for force to occur. Now, option C says D says an object remains at rest unless acted upon, which is Newton's first law of motion. So which means C is going to be the correct answer for this question. Now, option 12, if a particle moves with constant velocity vector, its acceleration is dash. We already did explain this already with constant velocity. Since the velocity is constant, it does not change, then the acceleration is going to be zero, right? But the fact that if velocity does not change, then acceleration will always be zero. Now, question 13 says the velocity of an object with respect to itself. We already did this earlier. I don't know. Repeat questions. So this one is zero. Then question 14, right? Question 14. Right. So now this one says two trains approach each other on the same track. Train A moves 40 meter per second east and train B moves at 30 meter per second west. What is the velocity of A relative to B? What is the velocity of A relative to B? So now we are giving A and B, so which means basically we're just going to do VA minus VB, right? But how do we get our VA and VB, right? VA, that's train A moves east, right? It moves east, so it's going like this, right? Then the other one moves west, so it's going like this. So this one is 40 and this one is 30, right? So we have this. So now what we're going to do is we're going to assign one of them to be positive, right? The one that moves east, A, we're going to assign it to be positive. Then this one that moves west is in the opposite direction, so it has to be negative. Do you understand that? So now VA minus VB, which is going to be 40 minus 30, right? Because this VB is 30, right? But because we already assigned the east to be positive, then that means the west must be negative. So we have 40 plus 30, and this is equal to 70 meter per second. Now, how do we know whether it is east or west that it moves, right? Now, the value of this is plus 70, is positive, right? Since we already said that positive is for our east, then this means that it's going to move 70 meter per second east. So the relative velocity of A relative to B is 70 meter per second east, option B. So very, very simple. This is a trick. So just assign one sign, assign a sign to the first one. Then the second one that is moving in the opposite direction will take the negative sign. Then at the end of the day, after you calculate, if your answer is positive, you already know that it is going to be in the direction of the sign that you assigned, right? If it's negative, it's going to be for the opposite side. You understand? If you add minus, assuming we got minus 70 now, you know it's going to be 70 meter per second. It's going to be to the west if we got negative, right? Because we already assigned negative to west and positive to east. You understand? Right. So we have question 15 now. Question 15 says three vectors are A. Right. We have A. A is equal to 3I plus 3J minus 2K, and B is equal to minus I minus 4J plus 2K, and C is equal to 2I plus 2J plus K. Says we should find A dot product of B cross product of C. So we are going to do what is inside the bracket first, right? Following board math. So this is B times C, which is basically the vector, the cross product, B times C, cross product. So we are not just going to multiply them, we cannot just multiply. So cross product, you use we're going to be using determinants, right? So we're going to say I, J, K. Then the values for B, we're doing B times C. So these are the values we are taking, right? So for B now, we're going to put the values of B under each of them. So now B, for I, we have minus 1. For J, we have minus 4. And then for K, we have 2. Then we'll do the same thing for C, right? For C, for I, we have 2. For J, we have 2. And for K, we have 1. Then we're going to take the determinant, right? So to do this now, we're going to say I, which is picking the first let me use another color, right? We're going to use this first letter here, or the first number, whatever is first here, sha. So we have I, then the determinant of the remaining two rows, right? Determinant of, so we're going to cross out this part. Then this part, 4, 2 minus 4, 2, 2 and 1. We're going to take the determinant and multiply it with letter I. Then we're going to say plus the next number, which is j. Then we take the determinant. Then we'll be having j. We're going to cross out this part. Then we take minus 1, 2, 2 and 1. So we have minus 1, 2, 2 and 1. Take the determinant. Then we have plus k, which is the last one. Then we're also going to cross out everything that is on the horizontal and vertical of k. So we have minus 1, minus 4, 2 and 2 left. We have minus 1, minus 4, 2, 2. So we have this. So we're going to take the determinant now. You know how you take determinant when you have A, B, C, D. The determinant is going to be equal to A times D minus C times B, right? So we're going to have here I in brackets. So I'm going to have minus 4 times 1, which is minus 4, minus 2 times 2, which is 4, right? Right. So here I'm going to have plus J, right? Here I'm going to have minus 1 times 1, which is minus 1. Then I'm going to have minus 2 times 2, which is 4. Then I'm going to have the last one plus k. Then I'm going to have minus 1 times 2, which is minus 2, times 2 times minus 4, which is minus 8. So this is going to be minus, sorry. We have minus minus 8 here. All right. Let me just cross check to make sure that we're not making any mistakes. All right, for I minus 4 minus 4. So this automatically gives us minus 4 minus 4. So we have minus 8i. Then we have plus, here we have minus 1 minus 4, which is minus 5. So we are going to have minus minus 5j. Then here we're going to have minus 2 minus minus 8, which is going to be minus 2 plus 8, which is 6. We have plus 6k. So that means the cross product of b times c is equal to minus 8i minus 5j plus 6k. Right, let me just write this here. So b cross product of c is equal to minus 8i minus 5j plus 6k. Let me clean so that we have enough space to solve the rest of the question. So now I've done the first part, right? And now the we have the dot product to do, right? So the dot product of A, dot product of B cross C. So this is what we have left. So this means we're doing 3i plus 3j minus 2k, because that is A, right? Times the dot product of the cross product B times C, which is minus 8i minus 5j plus 6k. And you know how dot product works. We only multiply the first term here, that's the value of I, the one that has I with the one that has I here, the one that has j with the one that has j in the second one. We do not multiply variables that um we do not multiply we do not use one variable to multiply everything, right? So we're not going to use 3i to multiply everything in the second one. We're just using 3i to multiply only minus 8i, because that's the only variable that has an I. Do you understand? All right. So now we're going to be having 3i. Sorry. So we're going to be having just the numbers, right? We're not going to multiply the I together, but the value, the coefficients of the I and the coefficient of the j and the coefficient of the k will multiply their correspondence in the other bracket. So we are going to be having 3 times minus 8 plus 3 times minus 5 plus minus 2 times 6. So 3 times minus 8 will be minus 24 plus minus 15 plus minus 12, right? So we have minus 24, then we have minus 15 minus 12. All right, so I think I made a mistake when we were doing the determinant, right? Whenever you have determinant I, j, k, right, you're taking determinant of a 3 by 3 matrix, right? This is going to be plus, minus, plus, right? So we ought to have add minus when we add after the I, the j, we ought to add minus here. So I omitted that. So when you are doing your own calculations, please make sure that you do not omit that. So we have that. So there's supposed to be minus there, meaning that our j, the answer for our dot product here, we're supposed to have plus, right? Because when you put minus times minus, you get plus. So this is supposed to be plus 5. We have plus here. We have plus 15. We have plus here. So by the time we add this, so minus 12, 24 15 minus 15 minus 12, we have minus we have plus, sorry, we have plus 3, and this gives us minus 21, right? So from our options, we have minus 24, 24, minus 12, and 12. So I believe that it is probably maybe one of the options was mismatched, or probably the question itself, the person that wrote down the question made a mistake, but minus 21 is the correct answer. So this is how you do it. So you do the cross product first. You go for the board mass. So you do the brackets, the cross product using your determinant, and then you do the dot product, multiplying the coefficient of I in the first bracket to the coefficient of I in the second bracket, with addition added by the coefficient of j in the second bracket multiplied by the coefficient of j in the second bracket, plus the coefficient of k in the first bracket multiplied by coefficient of k in the second bracket. So that is for question 15, and then we can take question 16, and then we move on to the next one. Right. So now for question 16, we have, which law of motion explains the collapse of a support due to heavy load, right? A support was carrying a load and then it collapsed. We have the first law of motion, which talks about body at rest, right? Now, the question does not tell us anything about a body being at rest or in motion, right? It just says that it's carrying a load. That means option A is wrong. Then option B, we have second law of motion. And the second law of motion tells us the relationship between force, mass, and acceleration, which is we do not actually see that in this question, right? So option B should be wrong. Then option C says the third law of motion. What does the third law of motion tells us? It tells us that action and reaction are equal and opposite, basically. Now, and that is correct. I will explain why. Now, for a body to be carrying a load, right? So let's say this is the slab and it's carrying this load. Now, one thing I want you to understand is that this body here is exerting a force downwards on this load, and this body that's carrying this load is trying to counterbalance that force. Now, if the load of this force is more than what this slab can handle, it will collapse, right? So the action of this body, right, is now too much for this body to handle, right? So that is why it fell down, and that is why option C is the correct answer for this question. Now, option D is very, very tempting to pick because option D says the law of gravitation. And now we know, according to the law of gravity, that everybody that goes up must come down, which is what this question was trying to portray. But the question said which law of motion, right? Don't get it confused. So that means option C is the correct answer, and we can move to the next question. Question 17. A car of mass 16 kg moving at 4 meters per second collides inelastically, that's a key word, inelastically, with a truck of mass 7 kg moving at 8 meters per second in the same direction. Find the final velocity of the system. Now let me explain something before I start to solve this question. It has to do with elastic collision, inelastic collision, perfectly elastic collision, and perfectly inelastic collision. For elastic collision, right? The kinetic energy is always conserved, as well as the momentum. For elastic, it is conserved. And the bodies, when they collide with each other, they do not move in the same direction. Do you understand? Right? For elastic collision, kinetic energy is conserved, momentum is conserved, but the bodies move apart, they separate. That means when they collide, they separate. Just like two balls. When you kick two balls together and they hit themselves, the two balls will go their separate ways. You understand? That is an example of an elastic collision, right? Now, for inelastic collision, kinetic energy is not conserved. For inelastic collision, kinetic energy is not conserved. Why is it not conserved? Because some part of the kinetic energy is lost due to it, is lost to it, right? So once it is lost to it, it means that it is not conserved. But momentum is conserved. The momentum is conserved. For inelastic collision, when the bodies hit themselves, they join together and then they move together for inelastic collision, right? And then we have perfectly elastic, which has the same properties as elastic, and perfectly inelastic, the same as inelastic collision. Now, where there is difference between them is in their coefficient of restitution. Coefficient of restitution is given by letter E, right? For elastic collision, E is less than 1, but it is greater than 0, right? For perfectly elastic, E is equal to 1. This is the difference between them, right? Because for the both of them, both momentum and kinetic energy are conserved. The bodies do not stick together. But the coefficient of restitution for the both of them is different. For E now, E can be 0.8, 0.7. But for perfectly elastic, it is always equal to 1. Then we have inelastic collision, right? For inelastic collision, the coefficient of restriction is also less than 1 and greater than 0. But for perfectly inelastic, the coefficient of restitution is always 0. Do you understand? So now let's solve this question. Now I've already said that for inelastic collision, momentum is conserved, right? Now what's the formula for momentum? Momentum is mass times velocity. Mass times velocity, right? Keep that at the back of your mind, right? So we have mass times velocity for momentum. Now, the question says a car of mass 16 kg, this is M1, the first mass, 16 kg, moving at 4 meter per second. This is the initial velocity of that mass 1. So initial velocity U1 is going to be 4 meter per second. Collides inelastically with a truck of mass, this is the second body now, cause of mass 7 kg, moving at 8 meter per second. So the initial velocity of the second body is 8 meter per second. Now the question could come in this form: a truck of mass 7 kg at rest. If it's at rest, then that means your initial velocity is going to be 0. Do not mix them up. Now the question says find the final velocity of the system, which means we are looking for V. Remember that for inelastic collision, the bodies will join together, right? So because they are joining together, their mass will now be M1 plus M2 because the bodies join together. And because they join together, it means that they are going to move at the same velocity. So that means that this is the formula for the other part. So we're going to have in M1 U1 plus M2 U2, right? Because this one now is the velocity of the first body, the velocity of the second body is equal to M1 plus M2 times V, right? Because inelastic collision tells us that momentum is conserved. So that means the momentum of the first body plus the momentum of the second body added together is equal to the momentum when the two of them are moving together because it is conserved. No energy is lost, no momentum is lost. No, sorry, no energy is lost, but no momentum is lost. So because there's no momentum lost, then the bodies, when they move together, they will have the same magnitude of momentum as they did individually added together. So now let's solve because we have our formula now. So we have 16 times 4, right, plus 7 times 8 is equal to M1, which is 16 plus 7 times V, which is what we're looking for. So 16 times 4 is 64 plus 56 is equal to 16 plus 7, which is 23 times V. So 64 plus 56 will give us 120 over 23 is equal to V. And then our final answer will be, I think this should be 5.1. Not with the calculator, but this should be 5.1, right? And this is our answer. Very, very simple stuff. Very, very simple. And then we'll go to question 18. We go to question 18. All right, question 18 says the motion is defined relative to dash. Motion is defined, and option A we have reference frame, option B absolute frame, option C center of the earth, option D another moving body only. Option D is obviously very wrong. Motion is not defined relative to another moving body only, right? It could be to itself. Because see the question that we're looking at, we say motion relative to itself. So if we can have to itself, then that means to another moving body only is obviously wrong. Then we have to the center of the earth. No, motion is not defined relative to the center of the earth. It's not defined relative to absolute frame. It's defined relative to reference frame. So there must be a reference. The reference can be itself, can be another body. So that's why option A fits best, and that is the best option for this question. Now, question 19 says, given A, all right, so it says given A is equal to 4I plus 2J minus K, and B is equal to minus 3I plus 4J plus 2K. Find the angle between A and B. Now, whenever you are given two different vectors and you are finding the angle between them, what you are going to be using is cos theta is equal to A dot B over the modulus of A multiplied by the modulus of B, right? So theta is going to be equal to the shift cos, arc cos A dot B, the dot product of A, modulus of A multiplied by the modulus of B. This is the formula. But if it is just one, let's say you are given A equal to 2I plus 3J. Now the angle here is going to be tan theta is equal to B over A, right? Where this is B and this is A, right? So this is difference, and this is when you use these two formulas. Right. So now let's solve. So we have this now. So we're going to find the dot product first. Remember, so that's going to be equal to 4I plus 2J minus K dot product minus 3I plus 4J plus 2K. Remember, I told you that the coefficient of I here will multiply the coefficient of I in the second one, and we'll add it with J and K likewise. So we are going to have 4 times minus 3 plus 2 times 4 plus minus 1 times 2. So here we have minus 12 plus 8 minus 2. Minus 12 plus 8, that will be 6. So we're going to get in 6 for this question. Yes, we're going to have 6. Okay, we're going to have minus 6, sorry. So this is minus 6. So the dot product is minus 6. So I'm going to put that up here. So now we're going to find the modulus of A and the modulus of B. All right, so we're going to find the modulus of A and the modulus of B. So how do we find the modulus of A? To find the modulus of A, basically we are going to say this is equal to x squared plus y squared plus z squared. Now for A, this is our x, this is our y, and this is our z, right? The coefficient of I, j, and k. So for I, we're having 4 squared plus 2 squared, then plus minus 1 squared. So we have root 4 squared, which is 16, plus 2 squared, which is 4, plus 1 minus 1 squared, which is 1. So here we have root 21. So our modulus of A is equals to root 21. Then we're going to find the modulus of B, and then we can now compute our answer and solve. All right, so now for the modulus of B, we're going to be doing the same thing, x squared plus y squared plus z squared. So now we're going to be having the roots, x squared minus 3 squared plus 4 squared plus 2 squared. So we are going to have here minus 3 squared, which is 9, plus 4 squared, which is 16, plus 2 squared, which is 4. So we have 9 plus 16, which is 25, plus 4. So this is root 29. So that means our modulus of B is equal to root 29. So now that we have this, we can just plug in our values, and then we solve, get our final answer. So now, all right, so we have theta is equal to arc cos of A dot B. That's minus 6 over root 21 times root 29. And then you do this, and then you get your final answer. Already I can tell you that the options are not correct, because you cannot do this and get 30 degrees or 45 degrees or 60 degrees. That will be calculated here, so I cannot compute this totally. So now the issue is not with the options, it's probably with the question. Maybe there's a sign mismatch, or a number that was mismatched. But this is how you calculate it, right? So now, for if these were the exact numbers in the question, then this is going to be our answer, right? But because there's a mistake somewhere, that's why we're not having the answers as in the option. But this is very correct. And then we go to question 20. We go to question 20. We're going to be stopping at question 30. So let's do question 20 now. So say which of the following is not correct for unit vectors. Now this has to do with multiplication of the different symbols. I'll just teach you a trick. So we have here I, J, K, right? So we're going to be multiplying them. Right. So we have I times J, right? Because we cannot have J times I now. We already have I times J. So we want to put another letter. So we'll put K, then here we'll put K times I. Now I times J is going to give you the third letter, which is K. J times K is going to give you the third letter, which is I. And K times I is going to give you the third letter, which is J. Now, when you reverse the order, it gives you the negative, right? So when you have J times I, it's going to give you minus K instead of positive K. Then when you reverse k times j, it's going to give you negative I, and when you reverse I times k, it's going to give you negative j. So now that we have all this, now let's look at the options. Option A, we have k times I is equal to j. We can see that k times I is equal to j. That is option A is correct. Now we have j times I is equal to k for option B. J times I is equals to k. J times I, this j times I, and we have minus k here, which means that option B is wrong, right? Option B is wrong. So let's check option C. We already know that option B is wrong, but let's just check option C and D to see if it's actually correct. So option C says I times J is equal to K. And now we can see I times J is equal to K, which is correct. Then option D, we have K times J equals to minus I. K times J here is equals to minus I, which is correct. So that means option B is the only one that is wrong. Because option B said that J times I is equal to K, which is wrong because J times I is equal to minus K. All right, let's go to question 21. Question 21 says the velocity of an object with respect to itself. That's a zero. We have seen this question a lot of times. And you can be so lucky that you see this kind of question, you see multiple times, and you just get your answer. Right. So I'm trying to push this up and make it bigger. All right. So now let's go to question 22. The dimension of density. All right. So first thing I told you, remember, you have to get the formula. For density, it is equals to mass over volume, right? And now mass is what? M. Now volume is length times length times length. So let's express this, right? Mass over length times length times length, right? I remember M, mass is M, right? And length is L. L times L times L. So we have M over L cube, which is M L raised by minus 3. Very, very simple stuff. And let's go to question 23. Question 23. For question 23 now, it says which is not a mathematical statement of Newton's law of motion? F equals to ma. That is correct from Newton's second law of motion. Mg is equals to n. That is not correct. It is not from any of Newton's law of motion. We have F is equals to mg, which is correct because it is the same thing as the first option, F equals to ma. Then D, if net force is equals to 0, acceleration is equals to 0, which is very, very correct, right? Because force and acceleration are directly proportional, right? So if force is 0, then that means automatically acceleration is 0. So option B is not correct. Then question 24, we have here if the velocity of A is 8 meter per second north and velocity of B is 6 meter per second south, right? So we have A to be 8 meter per second north, then the other one is 6 meter per second south. Remember, this one is not. So we can give this one positive and say this one is negative. Then asking for the relative velocity of A relative to B. So we are doing VA minus VB. So we have VA, which is 8, minus VB, which is minus 6, because we are saying this one is going to take negative, right? 8 minus minus 6, which is plus 6, that's 14. So now which direction? Because we already said north is positive, and because this 14 is positive, so that means it's going to be 14 meter per second north. Very, very simple, and that is option B. So now let's go to the last part of our questions. Question 25. If a body moves not, okay, it's exactly the same question of question 24, so you already know the answer. Then question 26. Say which of these is correct for an inertial reference frame? Which of these is correct for an inertial reference frame? Option A, acceleration, accelerating and Newton's law do not hold. B, not accelerating and Newton's law do not hold. C, accelerating and Newton's law hold. Not accelerating and Newton's law. Remember I told you initially that initial reference frame is true for Newton's first law of motion. So Newton's law must hold for an initial frame. But what does not hold is acceleration. An initial reference frame does not accelerate. Why? Because it is moving with constant velocity. So that means option D is going to be our answer because it is not accelerating and Newton's law holds. So let's go for question 27. Right. So question 27 now it says A minus B is equal to 2C. I think we already did this. And A plus B is equal to 4C. We already did this. I think this was question 4, if I'm not mistaken. Let me see. All right, question 7. So we already did this, so we'll just keep that. And then we'll go to question 28. Question 28. It says an object with a velocity with respect to itself is 0, is 0. We already did that. I've done this a lot of times. Then option 20, question 29. Say which of the following is not correct? Which of the following is not correct? We have A. Remember, I told you if the simplest way, just I, J, K. Then you multiply by J. Because we already have I times J up. We don't want to put two different. So we'll put K, right? Then I, right? And then we have this, right? So I times J will give you the third variable. J times K will give you the third one, which is I, the one that is missing. K times I will give you J, right? And then when you reverse it, J times I, you're going to get minus K. When you reverse K times J, you get minus I. And when you reverse I times K, you get minus J. Now let's check the options. Option A, we have k times j is equal to minus I. We have that here, so that means option A is correct. Now, option B, we have I times j is equals to k. Where is I times j? I times j is equals to k. That means option B is correct. Then option C, we have k times I is equal to j. Where is k times I? K times I is equals to j. Then option C is correct. Then option D, we have j times I is equals to k. This is where we have j times I is equals to minus k, not k. So option D is wrong. Very, very simple stuff. Then we'll take our last question. All right. So 30, it says a footballer kicks a ball with a velocity of 20 meters per second at an angle of 45 degrees. We'll find its range. Now, what is the formula for range? When we're looking for range, very, very simple formula. So we have range to be equal to u squared sine 2 theta over g, right? And g is acceleration due to gravity, which equals to 10 meters per second squared, except said otherwise. Now, if the examiner should tell you that use g to be 9.8, then use g to be 9.8. Right? Now, u is equal to what? U square, u is going to be 20. That's our initial velocity, which is what they gave us in the question, 20 meters per second. And then our theta is 45 degrees as said in the question. So r is equal to u square, which is 20 square, sine 2 times 45 all over 10. So r equals to 20 square, which is 400, sine 90 over 10. And sine 90 is equals to what? 1. So we have 400 times 1 over 10. So our range is equal to 40 meters. Option A. Very, very simple stuff. There's nothing difficult in physics. There's nothing difficult in physics. So I believe that with this, you should have a level of confidence going into the exam. I wish you best of luck.